Hello students, let us continue with module number 3, chapter number 4, metals and non-metals. Let us understand the reaction of metals with water. Reaction of metals with water. Metals react with water to form metal hydroxide or metal oxides and evolve hydrogen gas. Potassium, sodium and calcium react with cold water. Sodium react vigorously with cold water forming sodium hydroxide and hydrogen gas. Here the reaction is given. This is sodium atom. When it is dropped in water, it reacts very vigorously, even catches fire in the water, surface of water due to the formation of hydrogen gas. And that is sodium hydroxide formation, which is forming a very strong base called as alkali. The strong bases are called alkali. So here this reaction of metal with water gives you the particular hydroxide and hydrogen gas is evolved, which can be tested by bringing burning matchstick near the jar containing hydrogen which you would have collected. It makes a pop sound. Now, metals from magnesium to iron in the reactivity series. I'm going to show you reactivity series, and even already have shared the textbook, soft copy of chapter number 4 in your Google Classroom. React with steam but not water, not a cold water, to form the metal oxides and hydrogen gas. You take magnesium ribbon, it will not react with cold water, but steam or hot water, we can say, it reacts with magnesium to form magnesium oxide, and the same time hydrogen gas is liberated. It depends upon the type of reactivity of the metal. Many metals I told, potassium, sodium and calcium, they react vigorously with water, but again talking about magnesium and iron, they react with either hot water and steam, that you will be learning in further classes. Now, reaction of metal with dilute acids. When these metals react with dilute acids, it gives salt and hydrogen gas. You have to notify that even in this case also, when metals react with dilute acids, it also gives hydrogen gas and particular salt of that metal. Metals above hydrogen. In the reactivity series, metals above hydrogen in the reactivity series react with dilute acids, forming a salt and hydrogen gas. The evolution of hydrogen gas can be tested by bringing a burning splinter, or you can say a matchstick, near the mouth of the test tube. The hydrogen produced will make a pop sound indicating the hydrogen is produced in the or formed in the reaction. Let us go with sodium reacting with direct hydrochloric acid. It gives sodium chloride. Here sodium displaces this hydrogen to give hydrogen gas, and it forms sodium chloride compound, which is a salt. Iron reacting with hydrochloric acid to give ferrous chloride. Here the valency of iron is 2, hence the name ferrous chloride or iron chloride you can say, and valency of chlorine is 1. Hence they are interchanging the valency. 2 of the iron is given to chlorine and 1 of the valency of chlorine is given to iron. Hence the formula is FeCl2 and hydrogen gas is liberated. Same time aluminium with dilute hydrochloric acid gives you aluminium chloride and hydrogen gas. Here again valency of aluminium 3, chlorine 1, so interchanging it has AlCl3. This is the balancing part which we have to balance it, as you have learned in your 7th class, to balance the equation. Both left hand side and right hand side of the arrowhead, means the number of atoms should be remaining same at both the side, left hand side and the right hand side, otherwise it is not a balanced chemical equation. Talking about this last reaction, very important reaction because it does not need any balancing. Here zinc, when it is reacting with dilute sulfuric acid, it displaces hydrogen gas, which is forming again here and the zinc sulfate salt is formed. If you see, all the atoms toward the left and the right are same, hence no need to have a balancing in this case. Hence always we choose for an example if it is not specified, so that we should not be having a stress of balancing the equation. Next, we have reaction of metals with bases. Some metals like aluminium and zinc react with bases like sodium hydroxide or potassium hydroxide to form the corresponding complex salt with the evolution of hydrogen gas. Metals do not react with weak bases like ammonium hydroxide. So here aluminium and zinc react with bases like sodium hydroxide and potassium hydroxide, which are the strong bases, to give a complex salt, which you are going to learn in your future classes, further classes. With the evolution of hydrogen gas, metals do not react with the weak bases like ammonium hydroxide. So we can consider that ammonium hydroxide is a weak base. Now let us understand what you mean by displacement reaction. Already I have indicated in the previous reaction of the zinc and dilute sulfuric acid, that is a displacing. Displacement reaction, if you talk about a reaction or chemical reaction in which a more reactive metal displaces a less reactive metal to form its salt solution or from its salt solution. Okay, so here for example, when you say copper sulfate is in a solution form, aqueous form, when since iron is more reactive than copper sulfate, this iron will be displacing copper from this solution, from its solution, salt solution, and it will be set free. At the same time, iron sulfate will be formed, means iron will be combining with sulfate. It's just an example of, if you talk about the cartoon show Gian and Nobita. Here Nobita and I can say Suzuka, they are very good friends. Okay, this is a part we can say Suzuka for an example for the consideration. So when this is iron, the strength, more strength metal, which is we can consider as a Gian. Gian will since he is having more strength, he wants to have a friendship with Suzuka. So he will just displace Nobita because he is lesser in the reactive. It can be easily displaced, and hence it is set free. And now the Gian and Suzuka has become a good friend because of he is more powerful and has an capability to displace, more reactive. Okay, this only for your understanding. Okay, don't consider this in the examination or any writing part. Here if you talk this in the reverse, iron sulfate and copper again I can say copper cannot displace iron sulfate. Okay, because it is less reactive than iron, so the reaction will not occur at all. Metal reactivity series, already I was talking about, so let me tell you what is metal reactivity series. It is observed that some metals are more reactive than others. Based on the degree of reactivity, metals are arranged in a series called the metal activity series or metal reactivity series. The metal reactivity series is a list that arranges the metals in the decreasing order of their reactivity. Means the topmost will be having the more reactive metal, and the last will be least reactive. Let us have a look. So here most reactive metals like potassium, sodium, calcium are placed above in the metal reactivity series, and the least reactive at the down, and medium I can say moderately reactive, it will be here somewhere. Okay, so accordingly whosoever is present first will be most reactive, and accordingly they will be displacing the preceding metal element from the salt solution. So decreasing of metals have been arranged in vertical order with the most reactive metal at the top and the least reactive one at the bottom. Carefully see it, go through it, because this again is very helpful for your 8th as well as linked is directly with 10th class. Now, with the help of the reactive series, we can examine the reaction of metals with oxygen, water, acids, and other reagents. Potassium placed at the top is the most reactive, while platinum at the bottom is the least reactive. Already I told. Hydrogen, though not a metal, is included in the series because it behaves like a metals. Okay, okay. So it behaves like a metal and can be used as a reference to gauge their reactivity. Means we can consider that hydrogen considered to be whosoever is above hydrogen are more reactive and more reactive than hydrogen, and below are least reactive. Uses of few metals. Copper and aluminum are used to make electrical wires and even you can say utensils. Iron, copper, and aluminum metals are used to make utensils for cooking and for manufacturing machine parts because these are very good conductors of heat, and hence they are used for making utensils, and they are very good conductor of electricity. Silver, gold, and platinum are used to make jewelry. Aluminum finds extensive use in fabricating parts of aeroplane and spacecraft because since aluminum is light in weight, hence it is used for the purpose. Even mercury is used in thermometer. Okay, it's a mercury. It's the only metal present in a liquid form at room temperature. Uses of few non-metals. Nitrogen is used in the manufacture of fertilizers. Liquid nitrogen. Liquid nitrogen means near to be minus 96 degrees Celsius is the boiling point of nitrogen. So below, more below now minus 196 degrees Celsius, nitrogen turns into a liquid. Is used as a refrigerant. It helps in storing human organs meant for transplantation at low temperature in hospitals. Phosphorus is used in the match industry for making the matchstick and in the manufacture of fireworks. It is also used in the manufacture of fertilizers like superphosphates. Graphite is used for making electrodes and crucibles for laboratory use. It is used for making black lead of pencils, very common. It is also used as lubricant in the machinery oil because it is again very soft, and for making fuel rods in nuclear reactors to control the reaction. The last, sulfur is used in the vulcanization of rubber, which makes rubber hard enough to be used in tires of vehicle, because if you take a pure rubber, it will just wear and tear in a few kilometers, but addition of sulfur make it hard and even the flexibility, and even does not allow it to wear and tear at the faster rate. Let us go with what do you mean by alloy. Alloys are the mixtures of two or more metals or metal and a non-metal in either case. Note, an alloy is usually made by mixing metals in their molten form. Means you are going to melt, if you are making the alloy, any two different metals are taken the molten form and mixed uniformly, or metal and non-metals are mixed uniformly to form this alloy, where the property varies and it differs from the actual metal, which help it protect from corrosion and give a different look, maybe attractive look, or many more. There are the properties. Let us go with the example. This chart shows you about, suppose, brass, the I can say golden color utensil in your residence. They call as brass, which is nothing. It's not a gold. It is the copper, 60% copper and 40% zinc. It is especially used for making musical instruments, utensils, electrical fittings. Okay, in the switchboard, the back part you say it's the yellowish color. That is nothing but a brass. Again, bronze, solder, stainless steel, magnesium, bronze, duralumin or duralium. These all are made for different cases. So please by heart this uses and by heart the appropriate composition for making the alloy. Let us have the practice work 3. Already I hope you have completed practice work 2 and 1 for model number 2 and 1. Write any one use of brass, just I was talking about before. Name the element used in the vulcanization of rubber. What happens when iron sulfate react with copper? Give an example of any two least reactive metals. Define displacement reaction. This all you have to do in your assignment sheet or in the notebook. Do complete, do create a doubt, and just solve your doubt when you are going with the online session with me, or any time on my WhatsApp number or in the Google Classroom. Thank you all of you.